All right, so this is going to be half of 6-4. We're going to, or I'm sorry, 6-7. Only half of it. We're going to talk about geometric sequences. We've already kind of talked about sequences before. We talked about arithmetic sequences, and that talked about when they add each time. It would be like if I gave you something like 3, 6, 9, 12. That's an arithmetic because you're adding each time, something like that. It doesn't have to start with 3 and then be the one that you're adding. I could do like 5, 7, 9, 11, right? I'm adding 2 each time. So we did this earlier in the year. But for now, we're going to be talking about geometric, and the difference is you're multiplying each time. So, and what we call is that we call it as a common ratio, what you're multiplying by. So the common ratio in this one is 3. We always want to start with our first term. That's a big important thing. So 4 would be our first term. We would call this A1. So if you remember, that was just a subscript. A1 means the first number in the sequence. A2 would be the second. A3 would be the third. A n minus 1 would be whatever one you're talking about. If I was talking about the fourth term, then this would be the term in front of the fourth, so that would be A3 if n equaled 4 in the example. So A1 is the one before it. An is the term I am talking about at this time. So those are going to be things that we're going to use throughout this section. And we're going to actually do this in 2 different sections, half today, another half probably on Monday, and then we're going to have a quiz on this. It's just going to be on this geometric sequences. Be short, pretty quick here. So for these, for the recursive, which means you're using the term, we talked about this when we did arithmetic, you have to know the one in front of it, which is nice, except for if I'm trying to do the 100th, then I have to use the 99th. But if I know the 99th, then the recursive. You see, to find the 1, you use the 1 in front of it, and you times it by the common ratio. So like if I wanted to find A10, I would use the 9th term and times that by my common ratio, right? So if I wanted to find the 4th one, I would use the 4th term and I would times it by, for this example up here, times it by 3, and that's how I would get to that 5th term. Use the 1 in front of it. That's called the recursive. When you're using the 1 in front, that is called the recursive. All right? So we've done this before. Now it's with multiplication. So this should look familiar. All right, so in this sequence, we have these numbers. And they want to know, is this a geometric sequence? If so, remember, it has to be the same number each time that you're multiplying by. So if this number times something gets you to 9.6, what you can do is you can take 9.6 and divide it by 12 and find out what number that is, and it's 0.8. You can then take this one, divide it by that, and make sure it's the same number, which is 0.8. Do the same with this one. Divide it by that, and you get 0.8. So yes, it would be a geometric sequence because you're still multiplying each time by 0.8. And then some of the other questions they ask, find the ratio. The ratio would be that number, that 0.8, and A1 would be 12. So your first term would be this. So this is how you would write the recursive definition. It would be AN equals 12, which means 12 is the first term. That's why n is 1. That means it's the first term. 12 is the first term, which it is, and 0.8 was our common ratio. And you would always times it by the 1 in front of it. That's a recursive. Okay? Next, the explicit, which is really nice, allows you to find whatever term you want. So if I wanted to find the 100th, and I didn't know the 99th, I would want to use this one. And what this says is it says you use, to find AN, you would take the first term, A1, and times it by the common ratio to the n minus 1 power. So if I wanted to find the 100th term, and let's say my common ratio was 2, I would do A at 0. Let's say my A1 was 5. My common ratio was 2. I wanted to find the 100th term. What is a 100? That is the question. What is that? I would take A1, which is 5. I would times it by 2 to the 100 minus 1 or to the 99th power. Sorry, my pen is not the best tablet on this. Let's see if this works. So that would make this the 99th, 100 minus 1, and minus 1. Okay? And so that's how you would, you put this in the calculator. So you go 2 to the 99th power, then times it by 5, and you would get the 100th term in the sequence. All right, so now what they're going to ask us to do is they're going to give us the recursive, and they're going to ask us to find the explicit. Well, the explicit needs a couple things. It needs A1 times R to the n minus 1. Well, the only things I need plugged in are A1 and R. Well, up here, this right here tells me what the first term is. My first term is 5. So this is going to turn into a 5 times, and this down here gives me my R, which is a half. So half to the n minus 1. And remember, you would have to do half to this power first, then times by 5. But that would be my answer for that question. All right, given this is the explicit. What would be the recursive? Okay, so the recursive, I need it. It's going to look like this. AN equals, and it's going to have this little thing, and you're going to have whatever your first term is at n equals 1, and then anytime n is greater than 1. You're going to have two different things that we're going to fill out. Well, first off, what is my first term? My first term is 3. That's where that came from. Remember, it's a n equals, they kind of switched it on you. They did, I think when we showed it to you up here, we did it as, yeah, oh no, they did it A1 first. So A1 is right there, that's 3. So that's my first term. And then 2 is the common ratio. And so if we go back up to what my this thing looks like, it's A n minus 1 times R. So it would look like 2 to the n minus 1 sorry, it would be it would be 2 times a to the n minus 1. Term in front of it, sorry. I had a massive mess up there. So it would just be 2 times, that's the R, times the term in front of it. That's all we need. All right? So then, if we had a phone tree, and when one person calls a certain number of people, and then those people call the same and so on, in the 5th round, we know how many people there are. So what they're doing is they want us to write an explicit definition for this to find the number of people called each round. So they gave me, they're telling me A5 after 5 calls, so I know A5 is 243 people. All right, and then if I look at this right here, A1 is going to be 3. So using that information, I can then find out my common ratio, which is what they did here. So they said, if you know A5, you can put that, so A5 should equal A1 times R to the n minus 1, and then you can figure some stuff out. Well, I know A5 is really 243, and A1 is 3. I'm going to times that by R to the, and I know this is 5 minus 1. So what I'm going to do is work backwards to get this R by itself. That's kind of what we've done on this last couple of things. So normally if I was going first, I would do R to the 4th power, because that's 5 minus 1. Then I would times by 3. But since I'm working backwards, I would divide by 3 first. And that's what they did over here. And that gets me my 81 equals r to the 4th power. Then you 4th root this to get rid of that, 4th root it. And when you do that in the calculator, that's where they get the r is 3. And so the explicit definition would be a1 times r to the n minus 1. And that's where they came up with that answer. And finally, how many people were in the 8th round of the phone tree? So now we can use our stuff that we knew before. So we're looking for A8, and that's going to equal 3 times 3, 8 minus 1. And then I can actually do this number order of operations. This is going to be 3 times 3 to the 7th power. So 3 to the 7th power first, then times it by 3 in the calculator, and that's where they get the 6,500. What in the world? 6,561. So that's how many people call me. All right, so that's geometric sequences. We're going to talk about series. Remember, series is when we take all those numbers in that sequence and we add them all together. All right, so you will have this. You need to take notes from this, and then you'll probably upload those notes for me. And then on Friday, you will have a worksheet that just talks about the sequences. And then on Monday, we'll talk about series. You'll have a homework on that probably on Tuesday. Wednesday, a short, quick review for Wednesday, Thursday, and probably another quiz, short quiz on Friday of next week that will just cover sequences and series of geometrics. All right. So I hope you have a good Thursday and take these notes, upload them, and then get ready for some practice on them on Friday.